Hi everyone, this is the help video for the Unit 5 test 5.03. And so this help video is going to summarize everything that we've covered in proportional relationships this unit. So the first thing that we're going to briefly review is plotting points on a coordinate plane. So just as a reminder, whenever we're plotting something on a coordinate plane, we work with the coordinate point in the form x comma y. So we start in the center and they gave us a coordinate point to plot 3 comma 4. We're going to move over on our x-axis 3 spaces, so 1, 2, 3, and then we're going to move up 4 spaces, and that will be where our point is plotted. So even though this is a review concept from a previous grade, it's still important to remind ourselves on how to plot those points because we do need to understand how to read a coordinate graph in order to answer most of the questions that have to do with proportional relationships. So when we're talking about proportional relationships and graph forms, proportional relationships follow two main qualities. And if a graph does not look like this, then it cannot be a proportional relationship. And those two qualities are written on the board here. The first one is it has to be a linear equation. So that means a straight line. So there cannot be any bend or any curve in the line. And as you can see in that graph, the yellow line is completely straight. It is linear. There is no bend or curve in that line. The second quality of a proportional relationship graph is it has to pass through the origin. And the origin of the graph is where your y and x axis intersect, which is the point 0, comma 0. So those are the two qualities. Has to be a straight line, has to pass through the origin. So when we look at these examples on the board here, we're given 3 graphs, and only one of these graphs is proportional. Now, this first graph is not proportional because it is not linear. There is bend in the graph. So that one's not proportional. The second graph, also not proportional. It does not start at the origin. So we look at the third graph. Does it have the two qualities that we need? It does. This is a proportional graph because it is linear. It's a straight line and it touches the origin. So it follows both the qualities we need for something to be proportional. Next, let's talk about equation form. Equation form has to be in the format of y equals kx, where k can be the value of any number. And really what's important to note here is you're just looking to make sure that there are no exponents and nothing is being added or subtracted. Whenever there's an exponent, that creates bend in our graph, which we already talked about. There cannot be any bend. And anytime something is added or subtracted, that will move it off of the origin. So looking at these equations, this cannot be an equation of a proportional relationship because it has an exponent. And this one cannot be an example of an proportional relationship in equation form because it has a subtracted by 7. So that moves it off of the origin. So that means the two answers on this screen that are proportional will be y equals 2x and y equals 7x. Both of those are proportional relationships. Now we can talk about constant of proportionality. And constant of proportionality is the consistent relationship between our x and our y value. So when you're looking at graph form, again, you're always in the form of y comma x. So I'm looking to see where does this line intersect with that grid to give me a few different points that I can work with. So I have the following points. I have 1 comma 2, 2 comma 4, and 4 comma 8. Now when I'm looking at my table, I can use this formula up here. K equals, so K stands for constant of proportionality, y divided by x. So I'm looking at all my y values and I'm going to divide my x value. So I have 2 divided by 1, 4 divided by 2, 8 divided by 4. And if all of these are simplified, you'll notice that they all equal 2. So that means the constant of proportionality in this graph would be k equals 2. The relationship between our y values and our x values is consistently the value of 2. And then we can also look at that in table form as well. Now that we know what the constant of proportionality means, we can look at the tables to see which one has a consistent relationship between the y values and the x values. Now, the work here is already completed for us, so we do not have to solve all of these, but they have set up all of the y values to be divided by the x values. And what we see is when they did that, there was consistently a relationship of y to x of 4/3. Now we can look at the green table. Take a look when y is divided by x every single time. Is there a consistent relationship? Is that relationship between y and x, is it the same for all the coordinate points? Well, no, we've got a 3/2, a 1, a 9/10. So clearly, this table here is the proportional table because there is a consistent relationship between y and x. And our second green table is not a proportional table because there is not a consistent relationship between our y value and our x value. Now we can talk about unit rate as well. So unit rate is similar to, or really the same thing as the constant of proportionality, but we do use a different form when talking about unit rate just because it is a real world scenario. We want to use the format 1 comma r, where r stands for the unit rate. So really what that means is if you're finding the unit rate of something, the unit rate is per one of something. So we want to find the value of y when our x value is 1. In the graph example that's on the board, which of the following ordered pairs represents the unit rate? Well, really what we're looking for is the unit rate is what is the value of y when our x value is 1. So B would be the answer. We see there's a 1 in place of our x value, and that's really what we're looking for. Again, we want to find whenever x is 1, then what is the value of our y? And finally, interpreting proportional relationships. When we're given a graph, it's important that we can read the graph for understanding and realize what the graph is talking about. So this graph has given us the point of 2,6. We really want to look at the legend or the labels on the axes in order to understand and get context as to what this graph is trying to tell us. So on the x-axis, we can see that it's been labeled ounces, and on the y-axis, we can see that it's been labeled seconds. So now we need to figure out what does the point 2,6 actually represent. I'm going to trace our coordinate point down to the x-axis, where the x-axis lines up with 2. So that means we're talking about 2 ounces, and then my y value is 6. So that means we're talking about 6 seconds. So what does the point 2,6 represent? Well, since our point lined up with 2 on the x-axis, to get 2 ounces of water in his water bottle, it takes Alvin 6 seconds. So again, in order to answer these, you want to make sure that you get context, understand what your y-axis and your x-axis is labeled, and then you can match up what the value of your coordinate point, what the data is telling you. So now that we have done an overall review of the unit, this is where the unit test review is going to come into play. So this is where you could really prepare for the unit test by seeing questions that are similar to what you will see on the test. So here is the first question: which written description best represents the equation? Our equation is y equals 4x. So as a reminder, that 4 next to a variable does indicate multiplication. So we're going to read the answer choices, and we're going to choose which one is expressing a multiplication problem. A, Peter loses $4 a day. Well, when I think of losing $4 a day, to me, that's subtracting 4. So I'm going to not think about that one just yet. B, Peter buys sandwiches at $4 per sandwich. Well, that sounds good because that would indicate multiplication. C, it took Peter 4 hours to shop. Or D, Peter's total was 4 hours. Well, if the total was 4 hours, then the 4 would be in the Y value. So the answer to this one is going to be B. And a key word to look out for here is per. We talked about that on the slide where we talked about unit rate and constant proportionality. Whenever you see per, that is going to indicate to you multiplication. And since we know that we are multiplying between our variable and our coefficient of 4, that per indicates to us that that is the correct answer because it is multiplication. Next, we can look at question number 2. Question number 2 is asking us to look at the tables and figure out which table shows a proportional relationship between x and y. And they have provided that formula for us again, y divided by x. And I can use my calculator in order to solve these if some of these division problems look a little bit tricky. So I can go ahead and start with my first one. Again, dividing my y value by my x value. So I'm starting off with 7 divided by 2, and that gives me a relationship of 3.5. Next, I have 14 divided by 4. Again, I'm just plugging these into my calculator, and that gives me, again, a relationship of 3.5. 17.5 divided by 5. Again, the answer to that is 3.5. And 31.5 divided by 9. Again, 3.5. So far this one looks good. I am going to check my work by doing the same problem or using the same formula to check for my second graph. So 7 divided by 1, I know that's a relationship of 7. 14 divided by 4, well, that's a relationship of 3.5. 16 divided by 6, that is a relationship of 2.6 repeating. And then 70 divided by 10 is a relationship of 7. So looking at these two tables, table 1 or table 2, it is clear that table 1 is the table that has that consistent relationship between the y and the x values. Table 2 did not have consistency in the relationship when y was divided by x. All right, and now an example for question 3. What is the unit rate? So when we're looking at unit rate, again, as shown on the board, we're looking for per 1 of something. So we want to figure out what is the value in the y spot of our coordinate point when x equals 1. So I'm going to take a look at this graph and I'm going to pick out any point that is on the graph. It does not really matter which one that I pick. So the first one that stands out to me is this one right here. It says that my x value is 2 and my y value is 10. So I know that my x value is 2, my y value is 10. I need to figure out what is the value of y when the x value is 1. So I'm going to look for what's the constant proportionality here. If I take y and I divide by x, well, 10 divided by 2 gives me a constant proportionality of 5. So that means in this situation, over the course of 1 minute, only 5 gallons was used. So my answer is going to be A. So again, find a point, find the constant of proportionality, and that is going to be your unit rate. All right, and now question 4. Question 4 is asking for the constant of proportionality in the table. We're using the same formula over and over again. The constant of proportionality is the y value divided by the x value. I can use any of the coordinate points that are in this table in order to solve this. The most important thing, though, is that you're taking from the y column first. That is your numerator. So we're going to work with the second one. Let's say my Numerator is 2, and my denominator, my x value, is 4. 2 over 4, what is that simplified? 2 over 4 is simplified to 1/2. Now, I could use any of these. Say I use that bottom coordinate point of 5 over 10. That fraction also is equivalent to 1/2. So the most important thing with number 4 is making sure that we are taking our y value and dividing by the x value. For question 5, we're going to see if we can find a table that matches the data in the graph. So we've been provided with some data, and we want to see if we can figure out which of the tables has the same constant proportionality. The first thing that I want to do is I want to figure out what the constant proportionality in the table or in the graph is, and then I can apply that to my table. So I see here that I have x and y, x and y. That means that my constant proportionality of y divided by x is 3 over 2. So I am looking for a constant proportionality of 2 over 3, my y value over my x value. So keeping in mind that this is a y value and this is an x value, I can look through all of my graphs. I'm going to start at the bottom. Right off the bat, this looks good. 2 divided by 3 is 2 over 3. But now what if I look at this one? This has 6 over 4. 6 over 4 is not equivalent to 2 over 3. So now I know that this cannot be a consistent relationship. What about the next one? I've got 3 divided by 1. Well, 3 divided by 1 is not equal to my constant proportionality of 2 over 3. Now I can look at my top graph or my top table, and every time y is divided by x, it does give me a relationship of 2 over 3, making the first table the correct table that matches the data in the graph. Question number 6 is asking for the constant of proportionality when given an example in word form. So Sam's grocery bill was $21 for 7 drinks. What is the constant of proportionality? So again, I'm trying to find per one. So if Sam spent $21 for 7 drinks, how much is being spent for 1 drink? There's 2 different ways you could solve this. You could set up your proportion, cross multiply, solve for the variable, or you could say, okay, well, what is 27 or 21 divided by 7? 21 divided by 7 is 3, and that is the constant of proportionality. So if Sam spent $21 for 7 drinks, that means it was $3 per drink. And just a few more. Question number 7 is asking us which of these equations is a proportional relationship? Now, just going back to what we discussed previously, anytime we have a proportional relationship in equation form, it must be in the form y equals kx, where k can be any number. What it cannot have is anything multiplied, added, subtracted, or exponents. Any of these things makes it no longer proportional. So looking at question 7, the only one that fits into that format is B, y equals 3x. There are no exponents and nothing is being added or subtracted. Question 8, what are the 2 qualities of a proportional relationship in graph form? Like the first page that we discussed at the beginning of this help video, a proportional relationship in graph form has to have 2 main qualities. It has to be a straight line and it has to pass through the origin. So the only answer here that matches with that would be B, linear and passes through the origin. Question 9 is asking us what observations we can make about the graph. This graph clearly has a couple of bends in it and it does not pass through the origin. So we would classify question number 9, this graph, as not proportional. So for question number 9, you are going to be given a graph and you are going to have to use your knowledge of proportional equations to classify what the graph is. And finally, question 10. Question 10 is asking us to analyze the data that is in the graph. A local theme park has a track with go-karts. What statement is true based on the graph? So just like we talked about previously, I want to get context as to what this graph is about. So I'm going to look at my x-axis and I'm going to look at my y-axis. My x-axis is labeled time in minutes. My y-axis is labeled laps completed. So I'm going to take a look at this point, 3, 2, and this lines up my x value at 3. So I know that this is talking about 3 minutes, and then my y value is 2 laps completed. So now I can use that to answer the question. I know that I'm talking about something is 3 minutes, and it took, and 2 laps were able to be completed. So now how does this match up with one of my answers? 2 laps was completed in 3 minutes. 3 laps was completed in 2 minutes. That's not correct. 3 laps were completed in 1 minute. Not correct. 9 laps were completed in 6 minutes. Not correct. So I know based on the context of what the label of my x-axis is and the label of my y-axis, I know that the answer is A. And that's the end of our review. So at this time, please make sure that you are going ahead and taking your 5.03 unit test. This test is worth 20 points. You will have 1 attempt at first, and then you may be eligible for an additional attempt after some more practice. So please reach out to any of your teachers if you have any questions, and thank you for watching.